Hello, this is David Todd and Nick Mackinnon of Onelight Corporation, and today we're going to go through the first video in our FAQ series, One-Click Spectral Illumination using the Onelight source. Nick Mackinnon is principal inventor of the Onelight system, and I'm helping customers with application solutions. Both of us have backgrounds in biophotonics. I'll start with briefly describing the Onelight Spectra system setup, showing the hardware, and then demonstrate the control software to show you what we can do. The Onelight is connected through a USB hub to a laptop running the SpectraGen software. The illumination light can be coupled to a light guide output you see in the upper right. An optional spectrometer and power meter can be connected also by USB for feedback and calibration. So with the laptop running our software, we can control the light color, intensity, and exposure. Here's the spectra source showing a light guide coupled to the output for use in imaging systems. Now you've seen the Onelight Spectra hardware setup, we're ready to move on to the OLSpectraGen software. You'll hear some background noise from our high-quality power supply. Over to you, Nick.
Hi, I'm Nick Mackinnon at Onelight Corporation, and I'm going to give you a bit of a tour of the Onelight software controlling the Onelight engine. We've already turned on the light engine. It's powered up, the boards are initialized, the drivers have been loaded, and now I'm going to start the software by selecting the Onelight icon for OLSpectraGen. When I select this, the window opens and the software looks for instruments. It sets a default lamp current and then navigates to the home screen. If you look down below, you can see that the light engine light shows green, showing it's found the driver and connected to the light engine. It also shows that the spectrometer light is green here, this indicator. It shows that it's connected to the spectrometer and it's receiving feedback measurements from the spectrometer. The first thing we typically would like to do is set the lamp current up to the normal operating current. So we've set it to maximum current here for maximum brightness. You can see that there's an information screen here that indicates the serial number of the unit. The fact that the lamp is on, the lamp current is now set to 100%, and some information screens that give you voltage, current, monitor fan speed, and have some information about current versions of software and so on.
Thanks, Nick, for showing us the Onelight system setup. Now I just want to highlight the first benefit. You can save setup time. With just a few clicks, you can have a fast startup compared to conventional illumination systems. And what are we seeing on this first screen, Nick?
To the right pane there, we see a spectral profile. That shows the spectral distribution of the light for which this instrument is calibrated. You can see it's reading wavelength at the bottom of the scale, and this is intensity. We don't show the amounts here, but you can see this in other screens. This is typically about 2 to 3 milliwatts per nanometer at the peak value here, although on some systems this can be higher. You can see from this one that the spectral range for this system runs from 413 to 686 nanometers. And when I go to turn the light on here, I can turn all the mirrors on in the DLP chip that controls our spectrum, and white light will come out of our system.
Thanks again, Nick, for showing us the power output provided by the Onelight system over a wide spectrum. That would work out to approximately 90 milliwatts over a 30 nanometer band. This is especially useful for imaging and microscopy applications, allowing you to simplify to one light source.
We have a number of headings up at the top. The instrument heading, which lets you set up certain parameters, load files, and exit the system. We have some setup menus here, setting up the light engine and the associated spectrometer for feedback. Some calibration functions, some data functions, and what we call our run functions for different modes of operation of the light engine. The Onelight software is intended to be demonstration software. Most users would use the Onelight drivers and embed them in their own software, controlling it from LabVIEW, Microsoft C++ programming, or other programming environments such as MATLAB.
As Nick just highlighted, our third benefit is that the Onelight software can be integrated easily using common and popular languages, lab control environments, and software, and no new programming skills are required.
Probably one of the quickest ways to get a sense of what the Onelight system can do is to go to our tuner module. The tuner module replicates many functions that you would find with a standard optical filter. As with the earlier screen, I can turn on the light, generate white light, and a full spectrum output. I can also select a sub-band, where I select a narrow band of light. I can control the intensity of this light with this slider bar at the side that raises the intensity up and down. And this is now not being controlled with the lamp current, as we did on the initial page, but it is now being controlled by turning on the mirrors of our DLP chip, the heart of the OneLight light engine.
So Nick, there are no other systems that can do this as a standalone system, right?
There's no other source that has the flexibility of spectral control of the OneLight system. Many sources can, such as AOTFs and liquid crystal tunable filters, can tune wavelengths, as we can do here, moving from red through the blue through violet. Very few of them can jump in the same way we can, randomly and quickly. Virtually none of them have the intensity control that we build into our system, or the temporal control.
OneLight's fourth benefit is that you can expand your lab and team's research results by using the only standalone system with no limit tunability and spectral control, intensity control, and time sequencing control.
I can now vary not only the wavelength that I'm selecting, I can vary the bandwidth. I can move that band anywhere in the spectrum that I like. I can control the intensity, and I can also control the duration of the exposure. I can set an exposure trigger. This is operating in continuous steady state output, but I can turn it off. I can go to the trigger function and do a quick exposure. There, I just did a 100 millisecond exposure, as you can see from the triggering setting here. I can change that exposure duration. I can make that a 10 millisecond exposure, do a much faster trigger. I could make it 15 millisecond exposure, or I could make it a much longer exposure, like a 1.5 second exposure, with incredible precision and accuracy, due to the speed with which the little tiny mirrors on the DLP chip can change.
So Nick, OneLight can do complex sequencing and opens up wide possibilities?
Yes, the tuner function here is really just showing you how you can control the DLP chip, but the fact that you can load any arbitrary pattern means you can change it at very high speed.
David again. We've covered a lot of ground today, and I want to summarize the benefits we can take away. The OneLight has easy startup to save time. You can replace most filter and source systems with OneLight Spectra. Fully configurable illumination programming. Full control of spectrum, intensity, and timing. So in this first video, we've shown how to set up and control custom color illumination precisely using the SpectraGen software and the OneLight system. Please join Nick and I for the next two videos in our series, 6 filters or a million, replacing filter systems, and number 3, would you rather measure or keep waiting for your filter to switch, where we cover sequencing. Thank you.